Everyone, in this video I'm going to walk through how to use EMU8086. It's a simple tool for writing and running basic assembly programs, and it's a great way to see how things work behind the scenes in your computer. So I'll walk you through the setup and show how to run your first program step by step. So first step is uh, you need to install EMU 8086. So go to this link. I'll attach this link below in this video, and just hit download button, and it should give you a setup file. Just run it like you would any other installer. Let me open it. It's here, yeah. So during installation you can pretty much just keep clicking next. uh, I left everything default. I have already installed it, so it says me, but yeah, I'm gonna just install it again. Yeah, that should be ready. So you'll get a readme file. Just go through it to get a overview of the tool, but it's not required. So once it's installed, uh, go ahead and open it. I'm gonna open it. So yeah, go ahead and open it up. It might seem a little old school, but it works, and honestly, it's one of the easier ways to try out assembly without a bunch of complicated setup. Uh, so when you open this, it'll basically, when you open it for first time, it'll ask you to create a new file. I've already created a new file, but if you wanna create a new file, just go to file, you find new, and you can, we'll be using the COM template. It's good for assembly. So I've already written a simple hello world program to just show how it runs. uh, Here, actually, so here, first we have a uh, dot model, small. This is basically, this just tells the assembler how we want to organize memory. In this case, we are saying the code and data will be kept in a separate small sections, which is a pretty standard for simple DOS programs. And next we have dot stack 100h. This sets up 256 bytes for the stack. So the stack is just a small chunk of memory used to temporarily store stuff when the program runs, like return addresses or values during calculations. And then we are going into the data section. So with dot data, here we are creating a string called MSG message that just says hello world, and the dollar symbol at the end is really important. DOS uses it to know where string ends when we ask it to print. Now on to the code itself. We start with dot code section, and label the entry point as main. We can think of it like a main function in other languages. And these two lines these two lines are basically just setting up access to our data. We are loading the address of the data segment into AX register and then moving that into DS, so the program knows where to find our variables. And next we have now we are getting to actual printing part, this part. So here what's happening is we are using interrupt 21h, which is like calling a built-in DOS function, setting to 09h. Basically tells it, hey, I want to print a string, and then we load the address of our message into dx, and finally call the int 21h to print it. Where we need finally we need to end the program properly, and for that, this part. So this is just telling DOS to terminate the program and return control to the operating system. The last line, end main, just tells the assembler this is where the program starts. So yeah, that's a complete hello world program in 8086 uh, assembly. Simple, but it shows how to close to the metal you get with assembly. You have to manage memory, call system functions manually, and control everything that CPU does. It's a great way to learn how computers really work under the hood. So you don't have to understand this program in this video. It's just an example for you to show how it works. So this is an editor. This is where you write your assembly code. It's basically just like a text editor, but made specifically for writing and uh, editing assembly programs. And let me actually, so before you run this, make sure you save it. Uh, Go to file, save as. uh, I'll just name it as test one, uh, and save it. Now when you hit the compile and emulate, so it looks like a little chip icon with a play, that's emulate. Let's compile it. Let me bring this window to you. So yeah, let me save it as test one. You'll see this window next. This is basically illuminate. uh, let's run it, and for some reason it opens up in a different window, but I'll just, so as soon as you run it, it's gonna show a bunch of windows, but don't worry, it's yeah, all these windows will pop up when you emulate. uh, so let me explain this. So this window, basically it's your output window. As you can see, hello world. uh, you'll see, if you have any errors in the program, there will be compiler messages at section. This is that's where you'll see errors, warnings, or confirmation messages after you compile your code. uh, and if something goes wrong, this is that will be your first place you want to check. Let me close this. So this is, so here we have registers window. This is super helpful. Basically this window is called emulator. uh, you'll get to understand everything later. Don't worry right now. So we have registers window. This is your registers window. uh, and this is super helpful. It shows you the current values stored in the CPU registers like AX, BX, CX, and so on. These are basically small storage areas inside the CPU where data is kept temporarily while your code runs. And yeah, that covers the basics. uh, Once you know each part does, it's really not that scary. EMU8086 gives you a full view of what's happening in your program, which is awesome for learning assembly step by step. Uh, and yeah, as I mentioned, if there's a syntax error, like if you have misspelled something or forgot a comma, EMU8086 will tell you. And yeah, I've definitely done that already a few times. Don't panic, just double check your code. uh, and when it opens in the emulator, you'll see a bunch of windows. Again, as I mentioned, don't worry. We'll at least at the beginning we'll focus on few things. uh, and we have step, which is basically to run one instruction at a time. uh, so you can watch the registers uh, on the right, on the left side. You'll see how things like AH or DX change. uh, and and if everything looks good in your code, you should see the output hello world, like hello world. And if you don't see it, double check the your string ends with the dollar symbol. That's important for that's important, or the BIOS function won't know where to stop. And the cool part here is that you're watching what CPU would actually do line by line. Um, um, you can see the code in the memory, the instruction pointer moving forward, and what's sitting in all the registers. Even if this looks weird right now, don't worry. It starts to make sense once you step through few more programs. So some of the common mistakes to watch for is you have to compile before you emulate. So clicking emulate without compiling first will give you errors. And use the org 100h at the top. It sets the starting address for your program. Without it, things will break. So when you print a string, it needs to end with a dollar symbol. uh, as you can see, hello world. um, that's how BIOS knows where to stop. And save your file before running it, otherwise you might be debugging an old version of your code. So that's basically it. You now know how to install EMU 8086. Write a super simple program, run it, through it to see what's happening. It's definitely a different way of thinking than Java or Python or anything high level. But honestly, once you get a hang of it, it's kind of fun. If you get stuck, just rewind, double check every step. And yeah, this is supposed to feel weird at first, and that's how you know you're learning something new. So yeah, all right, go try it out, and I'll see you in the next video. Thank you.